working as an assistant professor in the Department of Biomedical Engineering College. Okay. Today we are going to see about the experiment of ultrasonic blood flow measurement. Okay. So already we know. So if your organ want to work means it is in need of blood flow. Okay. So we have to need of oxygen for the organ tools for the cells to operate. Okay. So for that we have to calculate how much amount of blood flow will happen in our body. Okay. So normally we have a 5 to 6 liters of blood in our body. Okay. So if there is no blood means the organs won't function. Okay. So for that first we have to measure the blood flow. Okay. If you have an insufficient of blood means it is called as the anemic. Okay. So you can't able to work actively. Okay. So you have an insufficient of blood. Okay. So for that first you have to measure the blood flow. Okay. So for this there are so many methods for measuring the blood flow. Okay. So now we are going to see about the ultrasonic method. Okay. So already it have an electromagnetic method also. Why we are going for ultrasonic means so it has a more advantage. Okay. Nowadays in our biomedical field many of the equipment is working based on the principle of the ultrasound because it is a non-invasive, at the same time it is a non-radiation. Okay. So it just send a sound waves to enable to image the internal organs. Okay. So you can able to detect the ultrasound also. Okay. So mainly the ultrasound frequency. So our normal human being range is 20 to 20,000 Hz. Okay. So the ultrasound frequency range is about 20,000 Hz. So we can't able to hear the sound wave. Okay. So this is called as the ultrasound transducer. Okay. So have you know about the sensors and transducer? So sensor means it just measure the signal and convert in the form of the electrical signal only. So transducer means it measure all the signal. That means it sends all the signals, but it converts into any form of the energy. It is called as the transducer. Okay. So all the sensors can act as the transducer, but all the transducer cannot act as the sensors because sensors only give an output as in terms of electrical terms only. Transducer will give the output in terms of any form of energy. Okay. It may be of current, resistance, or else it may be of voltage. Okay. So it works on the principle of ultrasound transducer. Okay. So the ultrasound frequency is about 20,000 Hz. Okay. So it mainly based on the principle of the piezoelectric crystal. Okay. So piezoelectric crystal means whenever, so it nothing but it just whenever you giving an input as a mechanical, it will convert it into the electrical terms. Okay. So for example, in this transducer, inside this of this transducer, it consists of a piezoelectric crystal. Okay. So if you want to work the piezoelectric crystal means, for example, first you have to apply the voltage. Okay. You have to supply some of the electrical voltage. That electrical voltage will make the crystal to vibrate. Okay. That vibration is converted into sound waves. Okay. After that only the sound waves will travel into our body. So whenever the sound waves are traveling inside of our body, based on the tissue density, some of the tissue will absorb the sound waves. Okay. So some will absorb the sound waves, other will reflect that sound waves. This reflection again travel to the piezoelectric crystal. Okay. Those sound waves will converted into further into an electrical energy. Okay. So this is the principle of the piezoelectric crystal. Okay. It mainly works on the input will be a mechanical term and output will be in terms of the electrical signal. Okay. That means vibrate to electrical signal. Vibration means all the sound waves are traveling in the form of vibration only. Okay. So it is converted into electrical signal. This is the principle of the piezoelectric crystal. Okay. There is another term called as the inverse piezoelectric crystal. So inverse means it is exactly opposite to the piezoelectric. So it is vibration to electrical signal means piezoelectric. Electrical signal to vibration is called as the inverse piezoelectric crystal. Okay. It mainly works on the ultrasound. All the ultrasound will always works on the principle of the piezoelectric crystal. Okay. So the ultrasound can be used for both terms. One is for diagnostic, another one is for therapeutic. Okay. So the normal ultrasound we using for the medical term, it is around 3 to 10 megahertz. Okay. For example, 1 to 3 megahertz act as for the diagnostic purpose. For 3 to 10 megahertz it is used for the therapeutic equipment. Okay. So in this blood flow measurement, okay, so it consists of the sensors. Okay. So here we are using the ultrasound probe. Okay. So it is called as the ultrasound transducer probe. Okay. Then it consists of the audio. Okay. So whenever there is a blood flow, okay, so the blood will travel along the blood vessels. It will make a collision with the blood vessels. So making the collision, it causes the, we can able to hear the blood sound also. Okay. So for that there is a audio signal. So yeah, there also a headphone. Okay. You can able to hear the ultra blood flow audio also. Okay, so for that it is for intensity increasing. Okay, some persons are able to hear the audio of the blood flow, so we can able to increase it. Okay, it is mainly for the intensity purpose. Okay, so in this term there is a LED also. So why it is here means, so whenever you are hearing the sound, so already for example if you are making any of the sound means it will make a intensity, display the intensity. Okay, for that also here if it is you are increasing the intensity, if you can able to hear the blood flow means sound of the blood flow, so it will denotes the red light. Okay, if you can hear the sound at a high level means it will denotes the high level of the intensity. Okay, so it just display the whatever sound you are hearing and what is that intensity, just denotes the light LED. Okay, then there is a headphone for making the to hear the blood flow sound. Okay, then there is a output unit. Okay, so there is a waveform also. Okay, so for making the how the blood flow is varying and how it will flow, we have to measure it in terms of waveform also. So for that it consists of positive and negative. Okay, so this both are connected to the DSO, because DSO is mainly act as the output device. We can able to see the output in that DSO. Okay, so first there is also a ultrasound gel. Why we are using it means it is mainly for making the conducting pathway between our body and the electrodes. Okay, if you are placing the transducer means if there is any gap between our skin and the transducer means the signal will lost. We can't able to get a full signal. Okay, so for making the effective pathway we are using the conduction gel. Okay, it is mainly made up of the polyvinyl chloride. Okay, it consists of potassium and chloride ions. So mainly the ions will make a charge and it also making a conduction pathway. Okay, so whenever you are using the gel, okay, before going for the test means it will make a conduction pathway, at the same time it will reduces the impedance. Okay, have you know about the impedance? So it is exactly the same as the resistance. Okay, so whenever there is a proper conduction pathway, the resistance will decreases. For lowering the impedance also we are using this conduction gel. Okay, first we have to apply the gel on our body. Okay, so for normally whenever you are going to check the pulse means here it is called as the radial artery. If you place your thumb on this means you can able to feel the pulse of your body. Okay, same time you can able to measure the blood flow in the carotid artery. If in case, so in your neck it is called as the carotid artery. At the same time you can able to place the ultrasound transducer on the leg also. Okay, it is called as the femoral artery. Okay, so there is a blood vessel. In the blood vessel the blood will flow. So wherever it is a blood vessel you can able to feel the pulse rate. At that place you just place this transducer and hear the blood flow sound. Okay, first you have to apply the blood gel, ultrasound gel. So it is mainly for the making the conduction pathway. Okay, you just apply your gel. You can now just see there is a change of. Have you noted that? So whenever there is a sound means it will increases. I am not moving any of them, so that the LED increases the blood flow of sound of my blood flow. Anyone just to put a headphone and hear the sound. It will make a sound as like a murmur sound, just on-off sound only. So whenever the blood will flow, it will produce the sound like that. Okay, just murmur sound only it will produces. Okay, so there is the air gap also. Okay, so whenever you are taking that, you just reduce the audio and take it, because whenever you are taking the ultrasound there is a air gap, so it will make a high noise to the audio. Okay, so you just connect the output probe to the DSO. Okay, so this is the normal blood flow. So whenever you are placing the probe, there is a variations in the waveform because your blood is flowing. Okay, so it will produces the output of your blood flow also. So you just take a snapshot of it and paste it in your record. Okay, so it denotes the blood flow. Just take off your hand. Okay. already said you. So what crystal we are using in this ultrasound transducer? Piezoelectric crystal. Okay. So for driving the piezoelectric crystal, first you have to apply the electric voltage. Okay. So you have to apply the electric voltage. It acts as the bias voltage. So there is a crystal driver. So for applying the voltage, there is a amplifier. Okay. First there is a oscillator. Have you know about the oscillator? First at the first time only you are going to apply the input signal. After that it runs as a loop. It will produces the output without any of the input. Okay, so it is called as the oscillator. So this oscillator, because crystal is always working based on the principle of the oscillator. Okay, from this oscillator we are going to make a frequency multiplier, because each ultrasound is greater than 20,000 Hz. It's normal frequency. For diagnostic and therapeutic it will vary. So we have to set the frequency. That's only here it consists of a frequency multiplier. We have to select the frequency, how much amount we have to generate it from the oscillator. So there is many types of oscillators, Wayne bridge oscillator, then LC oscillator, Rossi oscillator. Many types of oscillators are present. Okay, so we are here using the Wayne bridge oscillator. Okay, so it will make it for the frequency multiplier. Okay, then it is connected to the amplifier. This amplifier will drive the crystal. So from this amplifier it will produce the electric voltage to the crystal driver. Okay, so this transducer, ultrasound transducer, act both as a transmitter and the receiver. It just transmits the signal, at the same time it receives the output signal also. So that's why this crystal driver is connected to the transmitter element and also the receiver element. So it is connected to the RF amplifier, radio frequency amplifier, and it is connected to the low pass filter. Okay, so why we are using low pass filter means we have to reduce the noise. Okay, so it just allow only the low signal to pass away. It minimize the high frequency noise. Okay, so and then it is connected to the audio amplifier, then connected to the speaker, because we have to hear the blood sound also. So there is a audio amplifier. So if you can't able to hear the sound means you have to increase the intensity. For that, here we are using the audio amplifier. Then it is connected to the speaker. So which may make it helpful for the to hear the sound. Okay. At the same time, there will be one is power supply and the voltage regulator, because so these are the main circuits present inside this equipment. So for that it is in need of power supply. Okay, so each circuit will vary. It is in need of power supply of various amount. Okay, so we are using here the voltage regulator. So it just make either it to 5 volt or else 10 volt. It just regulate it and given to all the circuits. So each circuit doesn't need a separate power supply. Just all the power supplies are taken from the voltage regulator. It will make a voltage to either 5 volt or 12 volt. Whatever it is in need of circuit, we will make it to the turn off. Okay. So this transducer acts both as a transmitter as well as the receiver.